Honors, this is a audio for notes on water. Period 1, we already discussed part of this. Period 8, we did not get a chance to. So again, you could fast forward through things that you need to spend time on. So water is a bent molecule. And it makes it polar because the poles don't cancel out. So what we have is in water, because you have a negative and a positive end, you have what we call hydrogen bonding, or you could call it a force. Sometimes it gets confusing. It is the force between the hydrogen and adjacent oxygen on another water molecule. So it's between molecules. It's between molecules. So that's why you see it as a dotted line for hydrogen bonding. Hydrogen bonding only occurs with fluorine, oxygen, and nitrogen. So just keep that in mind. So because water has hydrogen bonding, it has what we call high surface tension. And with surface tension, it is an inward force or pull, which tends to minimize the surface area. So water forms beads, or there's a picture in your book about a bug that can walk on water. And that's because, again, it has such a high surface tension. Well, the only way to break that is to interfere with that hydrogen bonding, and that is by adding a surfactant. And the surfactant you need to know is a soap of some sort, and we should know a lot about soap at this point. We should be washing our hands all of the time because of the coronavirus. So a surfactant of soap helps spread out the water. So when we were doing that activity the other day with putting beads of water or soapy water or isopropyl on pennies, you will see that the surfactant prevented it and kind of spread everything out. So vapor pressure is another property of water. Water has what we call a very low vapor pressure. And water, because of that, evaporates very slowly. And that's very important because if we didn't have that, we wouldn't have liquid water on the surface of our planet. So we need a large amount of energy for it to break those forces. So what I'm trying to show here on the left is this flask where we have water. And some of those particles have enough kinetic energy to go to vapor phase. In this flask, I will always picture it as closed because otherwise it's hard to imagine what vapor pressure means. So we have this vapor above that liquid. It's bouncing around the sides of the container and causing a buildup of pressure, which is force per unit area. Well, if I take isopropyl alcohol or acetone, either one of those, I will see that there's more vapor above that liquid. So therefore, I have more pressure that is built up. So that is why it will evaporate more, because again, it has less strong force as water does.